Are you tired of snapping taps and scrapping parts? Then this video is for you. Today I'm here to talk a little bit about thread milling. Now, depending on where you are in the industry, that may leave a bad taste in your mouth. The good news is, as it's become simpler than ever to implement it on your shop floor, and I promise this is something nearly anyone can do because there's special people everywhere. Let's go. All right, you can see I've got here the web page loaded. I've got the PDF for Allied Machine loaded with their Threadmill selection. Now they do have AccuThread, Threadmill USA, as well as an AccuThread T3, which has a 3 flute. They also have indexable solutions depending on the size of the thread you're getting into. What I want to talk to you about today, though, comes to implementation of thread mills and their Instacode generator. So clicking this, talking about online download and off. The way I prefer to do it is to use the download version. I don't have to worry about an internet connection, and if I ever need to update, they've got an offline version update to make sure my code output is always top notch. Once you have it downloaded and installed, you can see this menu right here. If you already know your thread mill, then you would click here. You just put in the item ID. If you need help finding your thread mill, they have an option that automatically looks up current thread mill solutions from them. And that's where we're going to be working today. As you can see, they've got a lot of options. API, BSP, BSPT, you can see them there. I don't need to read them to you. And when you download the app, you'll see it for yourself. It goes all the way down to UNJ, but we're going to go with NPT today. Select that, red box around, click next. Now, pitch. We're in NPT. I'm going with 27 because I know I'm programming an 8th NPT. So as long as your operators can read a print, they can select and pick out a thread mill. Click next. Now, external or internal to determine the approach and how that works. So I'm going to click internal. Major diameter, 1/8. And I'm going to do a right-hand thread. That's industry standard, at least where I am in the world. Next, now note they've got steel, high temp alloy, stainless steel, iron, non-ferrous, and hardened steel. This is going to change what options they give you to select for thread mills, which really reduces the what one should I use to speed you up to implementation. We're going to go with steel today. And then again, once you select your material group, you can select the hardness, you can select the nature. They've got some of the industry names here. So we're going to go with low carbon, 125 to 175. I'm going to pick solid, although it would show me their indexable options. And then I get the weld and shank or shell mill options there. I'm going to go for solid, and I'm going to go for non-coolant. Coolant options are great when you're planning to do deep holes or blind holes. I'm just doing the top thread. It's an entry port. I'm going to put a plug in it, really. So same reason I'm going to select a Threadmills USA. It's a great cutter. It's not the highest performance, but it has a great price. I just want to get the threads done. Next. Now you can select your machine interface, the programming standard here. They've got Siemens, Mazatrol, ISOG, Heidenhain, and Fanuc. How do you say it? I'm going to go with Fanuc. Fanuc? Oh, shit. Maximum RPM in my unit is going to be 15,000. Program units, I'm an inch programmer. Tool position 1, because that's quick to change anyway. Climb, because that's preferred. Now, if that's all you take from this video, climb is preferred, period. I don't have a single manufacturer right now that supplies thread mills that recommends conventional thread mill. Next, it's going to show you the SFM selected. You could override it here. I'm going to leave it with their defaults. I can always bump it up once I prove out the program. Same with the chip load. I'm going to do a 1-pass 100% cut. So I'm going to leave that at 9/10 per tooth. And remember, that's multiplied by the amount of teeth in the cut. I'm not going to add a spring pass, but it is a fantastic option if you need it. I'm not going to use it, but if you do select it, you can adjust the percentage. The default they recommend is at 98% because you're really just making sure you're there and you don't want to rub on the surface of your material. I'm going to click next. and there's my code. It's really that simple. It's going to go over all of the variables you put in so you can double check to make sure there was no typographical errors, and then it's going to give you your call. And something to remember here, looking at the code, is that this is incremental code, right? Like you see that G91. That G91 means as soon as you put the machine into position, it's then going to execute from that plane. So you need to make sure your Z's where you want to start, your X, Y positions are exactly where you want to start. If you're doing this on a rotary, you also need to make sure your A orientation is set, and don't forget to lock it before you start. The beautiful thing about this code being an incremental, one, wherever you put it, it's going to thread mill. So if you want to do a verification pass an inch above the part, you can do that. Two, you can take this code and you can throw it into a subroutine and store that on your machine. Then anytime you're doing 8th NPT in the same material, you can call up this code that you've already proven, which saves your operators time, especially in a job shop environment where you can jump from job to job to job. Every little tip and trick you can put in your hat and share with everyone in the shop is going to save you money. I appreciate you taking time to check out this video and learn a little bit more about thread milling and the solutions available to support you. If you have any questions when it comes to thread milling, your options, the manufacturers, the code generation, whatever that is, maybe you've got some new material or you're trying to troubleshoot an application, let me know. I work to support local manufacturers to reduce their cost of production so they can improve their margins and compete in the industry. Until next time, keep your spindles turning and earning.